In a previous video, we saw how, depending on what group an element was in, we could predict what charge would form, how many electrons that element would lose or gain to become what we'll see is a noble gas electron configuration. So magnesium, being in group 2, would become a +2 metal ion, where nitrogen, being in group 5, would gain 3 electrons and become a -3 charged ion. So when we combine the metal magnesium and the nonmetal nitrogen, we can do this kind of crisscross of charges here, where the charge becomes the subscript of the other element. So that's what those red and blue kind of crisscrossed arrows are indicating there, that we need 3 magnesiums with a +2 charge and 2 nitrogens with a -3 charge to create this neutral compound shown over here. So again, magnesium is +2, and if we have 3 of those, that would give us a +6 charge. And then for nitrogen being -3, if we have 2 of those, that will give us that -6. These components cancel out, and we get this neutral compound shown here. So again, ionic compounds will be electrically neutral. They will combine in a ratio that accomplishes that. And we can, again, kind of take that charge on the cation. It will become the subscript on the anion, and then vice versa. The anionic charge will become the subscript of the cation. If we have, say, a 2 to 4 ratio, or a ratio that is not the lowest whole number ratio, then we would divide by the greatest common factor to get the lowest ratio possible. So let's try this out in sample exercise 7 here. We have 5 different cases where we're combining different charges on our either monoatomic ions, or what we see over here with this phosphate, a polyatomic ion. So if we have +1 here and -3 over here, when we kind of crisscross these charges, we would have a subscript of 1 for our phosphate, our PO4. And then for our sodium, which is +1, we would need 3 of those. So the molecular formula then we could write as Na3PO4 for this compound. And let's make that a little closer together so we can tell that it's one compound. Now, when we have zinc, which is a +2 cation, and sulfate, which is a -2 charged polyatomic ion, when we crisscross those charges, we would see that we get a 2 to 2 ratio, which could simplify to 1 to 1. So we could just write this as zinc, Zn, and then SO4 for sulfate. And again, instead of writing 2 subscripts of 2, we would just simplify to 1. Let's see what happens when we crisscross iron 3 and carbonate here, which is -2 charged. So our iron is going to have a 2 subscript, so Fe2, and then we have to put our carbonate CO3 in brackets, and that would have a 3 subscript after it. So overall, we have Fe2, and then in parentheses, CO3 subscript 3. And again, that's because we need 2 irons with a +3 charge to balance out the 3 carbonates with a -2 charge. Then we crisscross over here with calcium oxide. So we're going to get a 2 to 2 ratio, which we can reduce to just 1 to 1, and we get CaO. And then last here, we have a -1 charge on our chlorine, so that becomes just a 1 subscript for our aluminum. But then we need, from aluminum +3, we're going to need 3 chlorides. So aluminum chloride, AlCl3.